Okay, so hello guys, welcome back to Gettobyte YouTube channel. Just a second, I guess. Yes. Okay, so hello guys, welcome back to Gettobyte YouTube channel. I'm sorry, it's just like small this. I'm just arranging the things at my back and my laptop in the starting 1 to 2 minutes. It's already 12:33 and the live was scheduled at 12:30. So let's just wait for a couple of minutes to start to join the people. And in today's live, we are going to cover the topic of chronology to learn the embedded systems. Okay, so I have got many requests from people and from the audience that they want to learn about these embedded systems, about these semiconductor technologies and these, but they often get confused that from where to start and how to start. Okay, so in today's video, we are going to cover this thing. Let's just wait for the audience for a couple of minutes and then we are gonna start it. I guess it's Sunday and most of the people are busy in celebrating their Sunday, having a relaxation day. Okay. Okay, so I have once like just announced it on the group also. So now let's just start with the video and with the live. Okay. So first topic that we are going to cover today in this topic is the chronology to learn the embedded systems. So now see when one once hear about the embedded system, there are a mix of profiles that people often get confused with. Okay, and profiles like those of embedded software, embedded hardware, then also a profile by the name of chip designing, which there is a VLSI, VSDL, digital and analog designing. So first of all, as a starting, when you want to start with an embedded system, first of all, get yourself a clarity that which profile you want to get into. And there are mainly three profiles in embedded systems: embedded software, embedded hardware, and the chip designing profile. Hello, sir. Is a fresher. I don't get the so everything asks for hands-on. What should I do? Free will, you have come to very right place. Okay, you will find number of like I am gonna just tell you about how you can do the hands-on experience and learning. Okay, so the stay intact till the live video. For the full live video, you will get the answer for your question. Okay, so yes, so I was saying that first of all, you should focus on finding your niche, whether you want to pursue your career in embedded software or embedded hardware or in chip designing. Guys, just a minute if you guys don't mind, let me just put my laptop on the charger. Yes. Okay. So yeah, and there are three niches: embedded software, embedded hardware, and the chip designing. Understanding these job profiles and these different categories is very important so as to know your understand so as to get an idea of what your interest is and how you want to dwell and build your career. Okay, so three major job profiles: embedded software, hardware, chip designing. We will just quickly go through on what does each profile do and briefing about it. So embedded software are the people who write the programming part for the microcontroller chips, microprocessor chips, Linux systems, IoT chips, or the different type of semiconductor chips. So embedded software is uses the programming plus the knowledge of hardware. Okay, so in this you can imagine yourself that you will be writing the code for the big systems like of automotive vehicles or avionic systems or of industrial machines, sensors, modules, and all those things. And you will be actually put to understand that how to interact a hardware with a software. In this interaction, in this there are number of software technologies comes up. Okay, then comes the embedded hardware, in which you will actually be building the PCBs, the core electronics, power electronics, power circuits, digital analog electronics, schematic layout, designing of an hardware of different type of hardware, 6-layer PCB, 12-layer PCB, 5-layer PCB, and then RF circuits, and number of all these things which are related to the core electronics, in which you will be actually physically, not like physically, but you will be designing the hardware, and then you will be putting it into a fabrication or manufacturing and all these kinds. And then comes the chip designing profile. Okay, and in the chip designing profile, what we do is we will in the chip designing profile. Yeah. In the chip designing profile, one is gonna actually design the chips. Okay. So, like in the embedded software and hardware are the people who directly works on the physical chips, and chip designers are the people who actually designs these small, teeny, tiny black chips according to your according to the company requirements or according to our application. So, in that there is a programming languages like of VLSI, VHDL, and all these things are used. Knowledge of core processors, ARM processor, RISC-V processors, these are also very much extensively used. Now, these three profiles that I have told are very in a hierarchical way, and these are widely known by the industries and the opportunities of which the India is right now having. But apart from these three, there are other job profiles also: field application engineer, testing engineers, process engineers, manufacturing engineers of our embedded or semiconductor profile, then supply chain engineers, and lots of other profiles. But right now in this video, we are going to focus on these three niches, because if we dwell into each and every niche, for that I will be coming with a specific videos for better clarity. Okay. Now one person has asked which of the three has more opportunity in the future. See, to be honest, if I say all the profiles have good amount of reach and good amount of opportunities, okay, but yeah, one can say because the as semi because all these three na are interrelated with each other. What one can say is that amount of resources which are there for a job profile and how easily you can learn those things. Embedded software is required. Why? Because if there is no software running on the microcontroller, then no end product can be made. But yes, in terms of the money, the embedded software and chip designing are the most lucrative. Okay, and those have the good amount of packages and requirements also. But it's not like that embedded hardware doesn't have lucrative packages and doesn't have opportunities. Those also have good amount of opportunities, but in embedded hardware, more niche and more refinement of skills is required. Okay, so as a fresher, it will be a bit easy for a person to enter into embedded software and chip designing and embedded hardware. But it's like embedded hardware have, like if you have a 1 or 2 years of experience, okay, and having the knowledge of core electronics, LTM designings, AC softwares, and in the hardware, there is also when people very often think that for the embedded hardware, there is no scope or there are a lot of investment has to be done in it. Okay, but it's not like that. Honest. For embedded hardware, you can download the PCB designing softwares. Okay, download it at your PC and just start with your designing. Okay, and then yes, for the hardware, you will be needing the tools like oscilloscopes and these power supplies and these things. But what I believe, if you invest the money on these instead of on other things, it will be for your self learning only. Okay, and for all these three niches, the common knowledge that one needs is of the microcontroller microprocessor understanding, data sheet reading, and the basics of embedded protocols and peripherals. Now, by MCU MPU understanding, what do we mean is there are mainly 2 to 5 type. There are mainly 5 type of semiconductor chips. Okay, out of these five, the two are microcontroller programming and the microprocessor programming, and microcontroller and microprocessor semiconductor chips. So knowledge of microcontroller and microprocessor plays a very important role also to get started with these profiles. Then comes the data sheet reading and the user manuals and the documentations. Okay, So it's very important to have a good amount of understanding on how to read the data sheet, how to read the user manuals of the different semiconductor chips, understanding of their features, specifications, data registers, and how do these work. And then comes the basics of embedded protocols and peripherals, like those of you are at I2C, SPI, and there is can how does the microcontroller timer EDC peripheral works and all these things. And these three common knowledge is required in each of these profiles. If you take any of these three profiles, okay. And for understanding with this common knowledge that we have just now stated and I have told, you will find that in our YouTube channel Gettobyte, there are good amount of videos which I have already uploaded for covering the common knowledge on these microcontrollers and on these microprocessors, and which are required in different embedded job niches that I have just now told. Okay, so one can look out this channel, our YouTube channel, and in that the playlist by the name of how to start with microcontroller technology. Okay, after that comes now in the video we are gonna, okay, Tijo has asked one more question. Tijo, I will come to your question after the like this covering the PPT slides, okay, and covering this basic chronology overview. Okay, so embedded software development when it comes now, like in this video we are gonna specifically focus on the embedded software cycle and the embedded software chronology, post which in the upcoming live sessions we are going to cover other job profiles also. Okay, so yeah, in the embedded software, one of the first thing that one should very well know about this software development kit around a microcontroller or microprocessor. By software development kit, what do we mean is the understanding of what all software tools, software stacks, and the environment that one needs to set up in a PC. So there are things comes up of like IDs, text, this compilers, debugger files, and then this GDB, OpenOCD, JNU GCC, RTD files, hardware section layers, bare metal files, ID setup, code configuration tool setup, all these things which ultimately makes a software development environment for a microcontroller or microprocessor. And then comes the understanding of the microcontroller or microprocessor peripheral understanding. What all peripherals are there? There are many advanced peripherals also in a microcontroller, like those of Ethernet, and then there are this watchdog timers, sleep modes are there, RTC timers are there, CAN protocol, flex protocol specifically for the automotive, then industrial automation protocols also, and then drone specific like UAV, drone CAN protocols, all these things. Different peripherals and protocols around the microcontrollers and microprocessors, those will give you an understanding that how do we have to interact the hardware with the software, how does the two devices communicate with each other, the two chips communicate with each other. And then in the last will be coming the understanding of MCU, MPU, RTD, middleware stacks. And in the third part, we will be having basically the knowledge of either Linux systems if you're working on a microprocessor, or if you're working on a microcontroller, then the RTD files, peripheral RTD files, and then these middleware likes of RTOS, sensor module interfacing device driver. So this chronology, first for understanding the software development kit, what are actual software tools are used for a software development around the microcontroller microprocessors, followed by the MCU peripherals and protocols, okay, and then followed by the software stacks. Either you are working on Linux or Linux based kernel systems, Linux based hands-on, and all these things are required. Okay, and for this also like in introduction embedded C, and yeah, one very important thing which is to be understood over here is the knowledge of the C programming language also. C programming language, because in software development we do actually the programming on the C processor, specifically on the embedded. Okay, and for that there is a playlist also uploaded in our YouTube channel, okay, introduction to embedded C and firmware development, in which I am this playlist is about 4 years old. So in some of the videos there are high as 20 or 30K views also. So I will recommend highly people to watch this playlist, in which they will cover the basics of software, embedded software development, covering from indeed this like C programming concepts to data types, software development kit to things also related. Okay, And now comes, okay, so now we have understood what chronology one has to follow. Now comes the question of type of job roles which are there in software development profiles. Okay, so job roles, okay, so there are mainly two kind of job roles, okay, development based job roles and the testing and validation based job roles. So in the development based job roles, there is a use like these are the two job roles and both have good amount of exposure, okay, and good amount of requirement in the industry, okay, because there are new developments happening. But it doesn't like that. People often take the testing and validation is not so good job role as compared to development job role. It's not at all like testing and validation will actually give you the much more application and use case specific knowledge, because once the development is done, then we have to test it in different scenarios. We have to think of different parameters, applications on how this the software system is gonna work. Okay, so these are the two job profiles which are there. Okay, and to know more about what kind of job profiles are there in semiconductor domain and what kind of opportunities are there for different job roles, we have uploaded a video by the name of General Semiconductor Videos in our YouTube channel, from which you can get more clarity and understanding on this thing. Okay. Then comes the last question, how to get started. Now, so as to get started with this embedded software development, first thing that one should do is take a microcontroller development board. Any microcontroller based development board. Preference with that microcontroller based development board is that is industry specific hardware and software tools, so that you get learning experience on educate on relevant and required tools, not on Arduino or ESP based, because Arduino ESP based hardware and software tools are not at all used in industry. Okay, then understand the CPU and the peripherals of that microcontroller from its data sheet. Okay, understanding from its data sheet will give you a very high amount of understanding that how to read the data sheet, how do the CPU work, how does the peripheral works, and then start doing the hands-on with the peripherals of the microcontroller and the CPU core. Test different features, make simple functional codes with the peripherals of the microcontroller, test different CPU features, and just see that how to use those features and how to use those CPU subsystems with the RTD files and the HAL files which are given of the corresponding microcontroller. Now it can be of any, if you are working on Linux systems, so Linux based software stack will be used, or if you are working on microcontroller and Windows based, so those RTD and HAL files and corresponding ID, integrated development environment, code configuration tools one can use. And then in the end, interface the different sensors and modules with the microcontroller. Okay, so in the first step, you will start deploying the projects, integration of different peripherals, and start understanding the middleware stacks like RTOS and all. Okay, so yeah, this is the educate and the recommended four steps that one should follow to get started with embedded software. Okay, now one of the viewer has asked that which microcontroller is good for studying. Okay, so for to them, I will to the new viewers also I will highly recommend our Electronics version 3 development board, which is based on NXPS 32 K144 microcontroller. Okay, and it is an industry specific protocol like microcontroller. Okay, and it has automotive based features and standards. So, and it is a new microcontroller development board as compared to Arduino ESP STM. So having a profile and the this thing in a resume that you have hands-on experience on STM K144, that is gonna lay a good amount of impact to the recruiting and the job people. Okay, next thing is how much this development board comes at. Okay, so this development board comes at right now at a price of 6,000 plus GST, but very soon we are gonna come up with a mixed sale on these development boards that I will keep you guys posted. But if you buy this development board with our AutoSAR MCAN layer course, okay, which is an automotive microcontroller programming course on this development board, so that with that course, this board is gonna cost you only 2.5k. Like course is of 9k, and this development board code in a additional cost of 2.5k, account to be around 11.5k. You will get board and a getting started course also with respect to automotive software stack. Okay, AutoSAR software stack. But if those people who find it very challenging, okay, that they don't want to directly start with the automotive software stack and this buying the course, so people can buy our free course on this SL2K14 for automotive MCU peripherals. And in this free course, I have briefed about different peripherals of a microcontroller. Of this microcontroller, I guess in the screen it is not so much visible, and I will take this as a feedback for my next lectures. Okay, but yeah, if students, people can enroll to the free course on this microcontroller, in which I have brief about different peripherals of this development board, how to use this development board. Not done the exactly coding part, but just briefing about it. Okay, so people will get a gist about it and understanding on it. Okay, so yeah, that's the ramp up for the today's live. Okay, and we have brief about the chronology to learn the embedded software development board, different type of job roles which are there, different type of job responsibilities which are there, and what kind of chronology one should follow, and all these things. Okay, in the last, I will just request the viewers that they can subscribe to us at our YouTube channel, in which we are continuously uploading many new type of content in the this technological awareness and technical type of videos on these topics. Okay, and if anybody have any other questions and anything to ask, they can put them in the comment section, and we will be coming again live on the YouTube next week on the same time with some new topic to make people aware and tell about new topics. Okay, and yeah, and I will request the people to follow us on our YouTube channel, in the Instagram, and okay, because here we are continuously uploading lots of technical content in an interactive way to make the people aware about these technologies. So yeah, that's the ramp up. If anybody have any other questions to ask, they can ask in the comment section. Okay, I guess not anybody have any particular question, and I guess Tejo, I have answered your question that which of the three has more opportunities and which microcontroller is good for studying. Okay, so I will see you guys in the next live. Okay, till then, stay safe, stay happy, be the skilled engineer and not just the graduated one. Follow us on our YouTube channel, follow us on our Instagram pages. Okay, to get updated with the latest content that we are continuously uploading on the semiconductor, automotive, and technologies emerging from different integrated chips.